Welcome back to another explainer. Today, we're diving straight into the absolute core of object-oriented programming. If you've ever wondered how static, lifeless lines of code transform into dynamic, secure, and fully functional systems, well, you're in the perfect place. We're going to unpack the essential triad of OOP: methods, constructors, and encapsulation.
So, here's our roadmap for today. First, bringing objects to life. Second, creating complete objects. Third, protecting your data. And finally, number 4, the complete business model.
Let's kick things off with a pretty simple question. Can a bank account exist without actually doing anything? Seriously, think about an account that has a balance and an account number, but literally no way to deposit, withdraw, or even check that balance. An object with just data and absolutely no action is completely useless in the real world. It has to perform actions to have any value.
Section 1. Bringing objects to life.
It's really crucial to separate data from behavior. Objects hold data, sure, like a car's brand or color. But methods? Methods are the crucial verbs. They define what an object can actually do. For a car, the methods are things like start, stop, or accelerate. For a student, it might be study or submit assignment. Methods are the active services that the object provides to the entire system.
Okay, so how do we actually build one? Let's break down the anatomy of a method. You can think of a method kind of like a mini program, or better yet, like an ATM transaction. First up, you have the return type. That's what you get back from the machine, like a printed confirmation receipt. Second is the method name, which clearly describes the action, like deposit. Third, the parameters. These are the specific inputs you provide, like the actual cash you're inserting. And finally, the body. That's the logic inside, the step-by-step actions the ATM performs behind the scenes to actually update your balance.
But listen, just because you can pack anything into a method certainly doesn't mean you should. Compare a chaotic design with a clean one. A process everything method that validates, checks balances, deposits, and sends notifications. That's an absolute nightmare to maintain. Contrast that with a simple deposit method. It does exactly one thing, and it does it exceptionally well. The golden rule here is one method, one responsibility. Small, hyper-focused methods are exactly how we build reliable, scalable systems.
Section 2. Creating complete objects. Now, this brings us to a really foundational concept: the constructor. A constructor is a very special method that runs automatically the moment an object is created. Its entire job is to set the object's essential initial values. You wouldn't want an object wandering around your system without knowing its own basic identity, right?
Think about it kind of like a factory. When you buy a brand new smartphone, it doesn't leave the assembly line as a totally blank slate. Its model, its color, its storage capacity, those are all permanently set before it even goes in the box. Well, code works the exact same way. When we manufacture a new student object, the constructor acts like that factory door. It ensures the student is stamped with a name, an ID, and a degree program before they ever enter the active system.
To really drive this home, let's see what happens when we skip this step. Without a constructor, we might create a student, but their name and ID are a total mystery. That's an incomplete object, and a massive risk for errors down the line. But with a constructor, the object is immediately complete, valid, and totally safe to use. Think of a hospital system. A patient record should never ever exist without a patient ID. Constructors guarantee completeness and integrity right from day one. You create it right once, and you use it with confidence forever.
Section 3. Protecting your data.
Imagine a giant bank vault. Should just anyone be able to waltz in and change an account balance? Obviously not. If anyone could just tweak the balance variable directly, it would be absolute chaos. We only want authorized methods to alter that balance. This is the beating heart of encapsulation, protecting your data by strictly controlling who or what can access it.
So, let's break down exactly how encapsulation achieves this lock and key system. We basically divide our class into two distinct areas: public and private. Our methods, the actions like deposit and withdraw, are public. They're the accessible interfaces that anyone can use to interact with the object. But the data itself, like the balance and the account number, is private. It is completely hidden away and protected safely from the outside world.
Well, how do we actually interact with that private data safely then? The standard approach uses controlled access through very specific methods called getters and setters. Need to see the balance? You use a getter, like getBalance. Need to update it? You use a specific setter method that checks the rules first. If data isn't kept private, malicious or just plain sloppy code could simply write balance equals 1 million directly into the system. Encapsulation forces everyone to play by the rules.
Section 4. The complete business model.
Let's put it all together and trace a real-world scenario from start to finish. Step 1, we start with a user story. As a customer, I want to deposit money. Step 2, that naturally leads us to design an object representing a bank account. Step 3, when a customer opens that account, our constructor initializes it, securely setting the account number and the starting balance. Step 4, when they actually hand over the cash, the deposit method performs the action securely. And finally, Step 5. Throughout this entire life cycle, Encapsulation ensures that the private balance data is perfectly protected. Its pieces, logic, and protection, all working beautifully together.
And you know what's really amazing? This isn't just for banking. This exact same logic scales to literally any business you can think of. Think about a typical food delivery app. If you were building this, you'd define your classes, maybe a customer and an order. You'd identify their core attributes, set them up properly with constructors, give them methods to place order or pay bill, and then completely lock down their private data using encapsulation. The object-oriented framework is just incredibly universal. Which leaves us with a final thought for you to ponder. We've seen how methods bring objects to life, how constructors make them complete right from the start, and how encapsulation keeps their sensitive data safe from harm. With this incredibly powerful triad in your toolkit, what real-world business problems could your securely designed code solve today? Thank you so much for joining me on this explainer. Keep building smart, and I'll catch you next time.